This is topic 15.1. We're going to talk about finding surface area and volume of spheres. So let's go ahead and just get started here. First things first, it says a sphere is the set of all points in space that are a given distance, the radius, from a given point, the center. All right, a cross-section of a sphere that has the same radius and center as the sphere is called a great circle. Now what you need to keep in mind, a great circle is always going to go through the center of the sphere. So there are actually multiple great circles on a sphere, okay? But it does have to go through the center of that sphere. So the center let me rephrase this. The great circle and the sphere, since the great circle has to go through the center of the sphere, hopefully we recognize that means that the sphere and the great circle have to have the same radius. So when asked to find the circumference of a sphere, you just calculate the circumference of any given great circle because it's going to have to be the same value. Now that top left line is pointing, we're going to label our sphere now. The top left line is pointing to the great circle. The top right line is pointing to the radius. The bottom right is pointing to the center of our sphere. And there are a couple of formulas you have to remember for this lesson. Surface area of a sphere is given by the formula 4 pi r squared. Volume of a sphere is given by 4/3 pi r cubed. Okay, so remember those formulas. You're going to need them for the coming tests and for this whole lesson today as well. All right, so let's start working some examples. In example 1, it says find the exact surface area of a sphere with a radius of 4. So the formula for surface area once again is 4 pi r squared. So we have our radius is already given to us, it's 4. So we've got 4 pi times that radius of 4 squared. So 4 pi times 16 gives us 64 pi. And we do have units, so make sure you put those on there. So centimeters squared. Okay, example 2, now we're finding the volume. So the formula for volume is, and I'm going to write it a little differently. I'm going to say 4 pi r cubed divided by 3. Same thing as what we wrote on the first slide. I just like to write it a little differently sometimes. Makes it a little easier to work with. So 4 pi times the radius of 18 cubed divided by 3. And we can type that in the calculator. And you would get 4 pi times 5,832 divided by 3. And you get 7,776 pi. And our units are centimeters, so we would put centimeters cubed on this problem. Now, if you'll notice on these two problems, we've said exact volume, exact surface area. Okay, keep in mind that means that you leave this in terms of pi. You do not round your answer. All right, so now in example 3, we're asked to round. We're told to round to the nearest thousandth. So here's what we know. A sphere has a diameter of 12. So if the diameter is 12, that means that the radius has to be 6. We're asked to find both the surface area and the volume. So surface area is 4 pi r squared. So 4 pi times 6 squared gives us 4 pi times 36, which is, I believe, 144 pi. And we could type that in the calculator to get it to round to the nearest thousandths. And I got 452.389 centimeters squared. All right, now let's find the volume next. Volume again is 4 pi r cubed over 3. So 4 pi times our radius, which we found to be 6 a minute ago, cubed divided by 3. When I typed all of that in the calculator, and I just did that all at once, I got 904.779 centimeters cubed. All right, example 4. This time we're given the volume and asked to find this exact surface area. So in order to find the surface area, there's one thing we need. We need to know what the radius is. Okay, so the first thing I would do on this problem is actually set up the formula for volume. So volume we know is 4 pi r cubed divided by 3. But we know what the volume is, so substitute that in. We know the volume is 4,000 pi over 3 equal to 4 pi r cubed over 3. Now there's a couple of ways to approach this. You can recognize that since both of the denominators are 3, that the numerators then have to be equal. So you could set 4,000 pi equal to 4 pi r cubed. Or what most people are seeing to do today is just to cross multiply. So you would get 12,000 pi is equal to 12 pi r cubed. Divide by the 12 pi. And you would get, the pi's nicely cancel here, and you would get r cubed is equal to 12,000 divided by 12 just leaves us with 1,000. Okay, now just a random side note here. If I were to say r squared equal to 25, how would I solve that for r? Okay, we would take the square root because it is r squared, so we would take the square root. Okay, now since this is r cubed, we are going to take what we call the cubed root. Okay, now your calculator will do this for you, so I want you to pull out your calculator real quick. I'm going to pull up mine. Okay, get it to turn on. Takes a minute on my screen. All right. And what you want to do, there is a math button right over here to the left of your calculator. It's the third button down. It says math on the button. Okay, click that button. And if you notice, the fourth thing down on that menu is a cubed root. Okay, so hit enter on that and then just type in the number you're wanting to take the cubed root of. And you should get on this problem for the radius to be just 10. Okay, so the calculator will do the cubed root for you. All right, now let's use that radius we just found to find the surface area. So surface area, remember, is 4 pi r squared, so 4 pi times 10 squared. And you should end up getting 400 pi for your answer there. And remember to leave it exact, so don't round that problem. Don't type that pi in the calculator. And I don't believe that there are units specified, so you don't have to put those on here. All right, example 5. It says if a sphere has a surface area of 36 pi square units, we're asked to find the exact volume. Sorry about that. We're asked to find the exact volume. Okay, so if I'm looking at this, I'm told the surface area. So what I'm going to do is start by writing out the surface area formula here. So surface area is 4 pi r squared. All right, but we know the surface area, so I'm going to put that in place here. And I'm going to start solving for r. So get rid of that 4 pi by dividing it over. And once again, the pi's nicely cancel. And we now have r squared is equal to 36 divided by 4 just gives me 9. And it is squared, so we just take the square root. And what do we know the square root of 9 is? 3. Okay, so we know the radius now. So we should be able to easily find the volume at this point. Remember, volume formula is 4 pi r squared, so, I'm sorry, r cubed, so 3 cubed divided by 3. And it does ask us to give this exact, so you would just do 3 cubed times 4 divided by 3, and I ended up getting 36 pi, and there are no units specified. All right, let's look at example 6. On example 6, we're told the great circle of the sphere has a circumference of 36 pi. So remember, we can easily use that information to find the radius of not only the great circle, but also the sphere. Okay, so I know the circumference, so I'm going to start by writing out the circumference formula. So circumference is 2 pi r. And like we said, we know the circumference is 36 pi. And then 2 pi r divided by 2 pi. Once again, the pi's cancel, so we are just left with r to be 18. Okay, so now to find the surface area. It is 4 pi r squared, so 4 pi times the 18 squared. And we do want this rounded to the nearest thousand, so we want to go ahead and type the pi in the calculator as well. So I just typed all of that at once. And I got 4,071.504, and there are no units specified. And then next we want to find the volume. So 4 pi r cubed, so 4 pi times 18 cubed divided by 3. Once again, we want it to the nearest thousand, so I typed all of that straight into the calculator and got 24,429.024. Please do pay attention to how we ask you to round. If we say to the nearest tenth, you would just have one decimal place. Nearest hundredths would be 2, and nearest thousandths would be 3. Okay? All right, example 7. It says, use the sphere graphed in the coordinate plane below to answer the following questions. Okay, we're asked to find surface area and volume. So the first thing that you would probably want to do here is to figure out what the radius is. Now, you can actually just count the radius if you would like, because we know that the center is right here at 0, 0. We can just count up 1, 2, 3, 4, 5 to realize that the radius is 5. But just in case this is not nicely centered at 0, 0, I'm going to go ahead and do distance formula to prove to you that this is in fact going to have a radius of 5. So our center is at 0, 0. And then I did y because I like to stay positive with my coordinates if at all possible. And y occurs at 3, 4. So square root of x2, which is 3, minus our x1, which is 0 squared, plus y2, which is 4, minus our y1, which is 0 squared. So 3 minus 0 is 3 squared gives me 9. 4 minus 0 is 4 squared gives me 16. So 9 plus 16 gives me the 25, and there we go. We get the radius is 5. Okay, so once again, if you don't have it centered nicely at 0, 0, just use distance formula to find the value of the radius. Otherwise, you can just count. If it's centered at 0, 0, just count up. Because remember, centered to the circle is going to be a radius no matter where it is. Okay, it doesn't necessarily have to be drawn on the picture for it to be considered the radius. All right, now in part A, it says, what is the exact surface area? So surface area is 4 pi r squared, so 4 pi times our radius we just found to be 5 squared, and you should get 100 pi. And in part B, it says, what is the exact volume? Okay, so volume is 4 pi r cubed, so 4 pi times 5 cubed divided by 3. And I'd got 4 pi times 125 over 3, which gave me 4 times 125 is just 500 pi over 3. And I realized at that point that I was not going to be able to reduce that at all. 503 don't reduce any. And so I just left it as 500 pi over 3. Please don't round that. Okay, please don't put 500 divided by 3 in the calculator to get a decimal answer. Okay, we want it to be exact. That means we don't want any decimals. Okay. All right, now in part C, it says, what is the equation of the line containing the radius of the great circle? So once again, we can really easily see, looking at the picture, okay, this time we have to look at the picture, that the radius goes from 0, 0 to that point at 3, 4. So I went up 4 and over 3, which means that my slope has to be 4 over 3, so 4/3. And then hopefully we're recognizing on this particular problem, the y-intercept is just 0. So our equation would be y is equal to 4/3 x. Okay, you could have absolutely typed in these two numbers into stat edit, stat calc, and you would have gotten the exact same answer. Okay, so that's a good practice here if you want to go ahead and make sure you remember how to do stat edit, stat calc with the two coordinates to find the equation, because sometimes again it may not be centered nice and pretty at 0, 0, so you may actually have to use that method to find the equation. Okay. All right, so these are all the notes. That's it for this particular lesson. You guys should start working on your assignment, and I hope you have a wonderful day. As always, if you need some help, just see your teacher in math tutor.